Ah, there you are. This is Michael A. Rathel from Westat, an employee-owned contract research organization nestled in beautiful Rockville, Maryland, in the shadow of the nation's capital. And welcome to my SAS Global Forum 2021 presentation, the SAS Dataset Characterization Utility. So SAS programmers normally reach for two tools when they receive a brand new SAS dataset. PROC contents, and you run a PROC contents so that you can review a data set's metadata, variable names, variable types, the lengths, labels, etc. And we also usually reach for PROC means so that we can explore the characteristics of the numeric variables, basic things such as the minimum values, maximum values, averages, and things like that. We're all familiar with what a PROC contents looks like, and here's an example of it. And you can see that we, in the alphabetic list of variables and attributes, we have variable number, variable name, type, length, format, and label. And this is from the sashelp.cars SAS dataset. Similarly, if we were to run a straight PROC means against that dataset, we would get an output that looks something like this. Variable name, label, the number of non-missing variables, the mean, standard deviation, minimum, and maximum. So we would have to go between these two reports to get a good, clear picture of what was in the data set. Well, the SAS Dataset Characterization Utility SAS macro program combines the best of both programs. In that, the output from it, you get variable name, variable label, the type, the length, the number of non-missing values, the number of missing values for both character and numeric, variable format. And for numeric variables, you get the min, the max, the mean, and the standard deviation, all in one place, all in one report. So the SAS Dataset Characterization macro program requires three parameters. Dir name is the directory holding the SAS dataset that's going to be characterized. DS name is the name of the target SAS dataset to be described. And report dir is the directory where the Excel report file is going to be written. Here's an example of what that would look like. And you can see we're invoking the macro char file. The dir name is Westat Rathel SAS Global Forum 2021. That's where the SAS dataset is going to be found. And what is that SAS dataset? It's pointed to by DS name. DS name is CARS test. That's the dataset I'm going to be using in the examples throughout this presentation. And report dir is where the report's going to be written. It's going to be written to Westat Rathel SAS Global Forum 2021. The program is actually broken into 5 different parts, part 1 through part 5. And the presentation is going to follow and illustrate each one of those parts of the program. Part 1 is use PROC contents to get variable information. Part 2 is access sashelp.vtable to determine the number of character and the number of numeric variables. Part 3, we're going to create separate data sets containing attributes of the numeric and the character variables. Part 4, merge the previously created data sets together with contents underscore vars. And part 5, we're going to create the report file. I'm also going to talk about how you can operationalize the SAS dataset characterization utility macro in your own environment, and then have some concluding remarks. So part 1, using PROC contents to get basic variable information. Here you can see the part of the SAS program. We start off with a live name statement, and the live ref is going to be SAS data, and it's going to live ref to the directory that was passed in with the dir name macro variable. We're using access equals read only to make sure that we don't clobber anything in that directory. And you can see it's a straightforward PROC contents. PROC contents data equals SAS data dot ampersand DS name, and that's the name of the SAS dataset, which is CARS test in this example. We're using no print because we don't really want an output in print format. Instead, we're going to save it into a SAS dataset called contents underscore vars. We're going to keep name, label, type, length, format, and variable number. And then after we do that, we need to do a little housekeeping. The variable type is set to 1, SAS sets it to 1 for a numeric variable and 2 to a character. A 1 and a 2 in our output is not very meaningful. So we're going to create a new variable called vtype, and we're going to set it to num if it's a numeric variable, and char if it's character. We sort the data set for future merging, and this is what it looks like. And you can see there are 15 observations, and they all contain one of the characteristics of one of the variable. We have name, length, var num, label, format, and vtype, and it's ready for future merging. Now that we've done that, we need to determine the number of character and the number of numeric variables, because we're going to need those numbers later on. And we do this by using a data null step, and we're going to create two macro variables. So we access sashelp.vtable, where live name equals SAS data, and the member name is the upcase of the data set name, cars test, and memtype equals data. And then we're going to take the number of character variables and put that into a macro called car count, and the number of numeric variables and put that into a macro variable called num count. And here's kind of what it looks like if we were to isolate that observation in sashelp.vtable. And you can see in the upper left-hand side, SAS data, car test data. So that's, we've got the observation we want. In the bottom right-hand side, you can see number of character variables. Numchar is 5, so there are 5 character variables, and numeric is 10, so there are 10 numeric variables in the data set. And then if we were to just put the char count macro variable and the num count, we would see that it's 5 and 10 respectively. And you'll see we're going to be using both of those macro variables in the near future. Part 3 is create separate data sets containing attributes of the numeric and the character variables. So if ampersand num count is not equal to 0, then we know that the data set has numeric variables, and we're going to do whatever follows that. If ampersand char count is not equal to 0, then the data set has character variables that are going to be processed in this part of the program. So here you can see in the code, if ampersand num count is not equal to 0, we're going to run a straight PROC MEANS against the data set, cars test, and then write the output out to a SAS data set. At the bottom of the screen, you can see what that looks like. Very, very unstructured, kind of very, very messy, but it has the basic information we need from PROC MEANS. So what do we do when we have something like this? Well, we use a PROC transpose and we linearize it, we flip it around. And you can see that this is a much more usable SAS data set now. We have 12 observations, and the first 2 are not going to be very useful to us, but underscore type underscore and underscore freak underscore, the name of those 2 variables. But the other ones, MSRP, invoice, engine, etc., those are the variable names that we're interested in the cars data set. So we use a data step to, first of all, retain total number of observations, and to specify the length of the variable name, the total number of observations. And I should stop for a moment and go back. At the very top here, there's a retain statement. We're going to keep and retain name, non-missing, number missing values, min, max, mean, and standard deviation. Then we get to our length statement, our retain statement. And if underscore name underscore is equal to type, then we delete it. I'm going to go back to the previous slide, and you can see we remove the first observation. If underscore name underscore equals freak, then we're going to set total obs equal to column 1 and delete it. I'm going to go back one more time, and you can see that that takes care of the second observation. And then for each one of the other observations, we're going to set name equal to underscore name, non-missing to column 1, min, max, mean, and standard deviation equal to columns 2, 3, 4, and 5 respectively. And then the number of missing values equal to the total observations minus column 1. Here's an easier way to see that. So let's take a look at observation number 5. And you can see that as it goes through this part of the program, name equals underscore name underscore. So if you, it's going to set name down at the bottom equal to engine size. Non-missing is equal to column 1, which is 411. The min, max, mean, standard deviation are set equal to columns 2, 3, 4, and 5 respectively, and you can see them down below. And then finally, we set the number of missing values equal to total observations, which was 428, minus non-missing, which is 411, so that ends up being 17. So we sorted for future merging, and this is what ends up popping out. And you can see that it's a nicely formed SAS data set. It has 10 observations, which are the 10 numeric variables in the SAS data set: cylinder, engine size, etc. The number of non-missing, number of missing, min, max, mean, and standard deviation. Now, what we need to do is we need to process the number of character variables. And basically what we're doing here is we're going to process the character variables, and we're going to keep name, non-missing, and number of missing variables. And we do this by first creating 2 arrays. The first array is called char_vars, and we're stuffing into it. We're using the _character_ automatic SAS facility to jam into it all of the character variables that are in an observation. We're creating a parallel array called missing_count, and we're setting it equal to the number ampersand car count, which is going to be 5, which is the number of character variables in the SAS data set, and it's a temporary array. And we're going to loop through in every observation, we're going to loop through all of the character variables. And if we find one missing, if missing char_vars sub I, then we're going to add a 1 to the missing count for that particular character variable. So we do this as we step through the entire SAS data set. At the very end, if n equals EOF, then we're going to step through one more time. I'm going to set name equal to the variable name using the vname function, char_vars sub j. Number missing, we're setting it equal to missing count sub j. And if it's set to missing values, we set it to a 0. And non-missing equals _n_ minus the number of missing values. That's an awful lot to digest. And a picture is always worth 1,000 words. So we sort it, and this is what we end up with. We end up with 3 variables: name, number of missing, and non-missing. And here are the 5 variables that were character variables in our SAS data set, and you can see them there. Now that we've done all the work of creating the data sets, it's time for us to start merging things together to get to our final data set. So we're going to merge the previously created data sets together with contents_vars, which was created in part 1 of the program. So if ampersand num count is not equal to 0, meaning that we have numeric variables, then we're going to do this next section. And of course, in our example, we do have numeric variables. So we start off with a retain statement so that we can keep everything in a specific order. We're going to retain name, label, vtype, length, var num, non-missing, num missing values, min, max, mean, and standard deviation in that order. And we merge the numeric variables in with the contents vars by name. Now, if ampersand char count is not equal to 0, meaning that we have character variables, then we do this next section. And then we merge into the previously created data set, final merge data, we merge in the character variables by name. When we do that, we end up with a really nice data set. And you can see here we have all 15 variables in one place at one time. And we have all of the variables, name, label, vtype, length, var num, etc. We have them in the order that we want. Now, there may be some cases where you get a SAS data set which does not have numeric data. If that were the case, and it's not the case in this example, then the code would fall into this section, and we would just be merging specifying just the character variables into the final merge, the final metadata value. All right, we've done all of this hard work, and now it's time for us to reap our rewards and create the report file. And we do this with, first of all, we have 2 ODS statements: ODS Excel file equals ampersand report dir. Now remember, that was one of the macro variables we passed in to this macro program. And that's going to have the full path to the directory where we want to write the report. You can see the slash in that and then ampersand DS name. So we're going to actually put the name of the data set in as part of the name of the output file. So it's going to be CARS test data set characterization report. And we're putting in the sysdate in case you run this on consecutive days. And it's going to be an Excel file. And we're also using ODS Excel, and we're giving the sheet name SAS Dataset Characteristics. And look at this. We're using simple old PROC print. PROC print with no observations, data equals final metadata, and we're specifying label. And then we are also specifying a couple of labels. V-type, we're saying that it should be called variable type, non-missing values, num-missing values equals missing values. Also, if this data set, in this case our data set does, if this data set does have numeric variables, and we're going to do this little block in this %f to %n, we're going to create a label for standard deviation called standard deviation, and we're creating a format for min, max, mean standard deviation of 10.2. We're specifying that format. And then down at the bottom, we're doing ODS Excel close and closing it. And look at this. This is what we've been working so hard to get. We're a very, very nicely formed report, which has the best of PROC contents and the best of PROC means. And you can see that it has variable name, variable label, variable type, variable length, variable number, non-missing, missing, min, max, mean, standard deviation, and if there's the format associated with it. And it's all in an Excel file that your users will be able to enjoy. Well, you may be thinking to yourself, I love this. How can I operationalize it in my own environment? Let's take a moment to talk about that. And of course, all of this information is in the paper. So what you can do is copy the SAS Dataset Characterization utility macro from the appendix and save it in a .SAS program on your own computer. I would suggest that you save it in your AutoCall macro library or save it in a directory of your own choosing. But if you put it in your AutoCall macro library, then you won't have to use the %include. If that's not doable, then you might want to use the, in Appendix C, I have execute SAS Dataset Characterization Utility Program. So copy that from Appendix C. And you would modify the %include statement to specify where the macro can be found in your own environment. It would look something like this. So %include, and that would have the full path to where you've saved the SAS Dataset Characterization utility in your own environment. And then you would have the invocation of the macro, %char file, and then dir name equals, ds name equals, and report dir equals. And that's how you can operationalize it in your own environment. Well, in concluding remarks, I want to say that this presentation introduced the SAS Dataset Characterization Utility macro. And it's a macro that you can use to create a digest report of SAS dataset that contains information that's normally found in either a PROC contents or a PROC means. You can have it all together in one spot at one time. Programmers can use this to get a solid idea of the characteristics of a brand new SAS dataset. And it's also a very good way to document a new SAS data set that you get from one of your clients or that you get from one of the other departments in in your own organization. This is the normal disclaimer slide that we like to have after every presentation. And then finally, I would like to hear from you if you have any questions or comments about this presentation. Zap me an email at michaelrathel@westat.com. Thank you very much for joining me for this presentation, and best of luck in all your SAS endeavors.